In this video, we'll see how to calculate an entropy change for a heat flowing into a system at a particular temperature. So this is the system right here. This is almost always the chemical reaction, but it could be a boring system like a block of metal that's not going to react. We are going to let some heat, say, flow into it. Okay, so from the system's point of view, it is positive Q. From the surroundings point of view, it is negative Q. So I guess I should label things up here. So this is my system or my reaction. And this is my surroundings, and everything taken together, of course, corresponds to the universe itself. Very big place. All right, I got a temperature, and this is going to be where the universe and the surroundings and the system's all at the same temperature. And I can show, actually, that the change in entropy for the system is equal to the heat that flows into the system divided by the temperature over which it does so. For example, if 100 joules of heat flows into the reaction at, say, 50 Kelvin, what is delta S? So we can go ahead and we can calculate. So flows into, so we interpret this as being a positive heat. So delta S here is going to be positive 100 joules. The temperature, we've got it in Kelvin. In fact, I did mention this earlier, but when we write this equation up here, this is going to be the absolute temperature. This is going to be the temperature in Kelvin. Heat is almost always going to be measured in terms of joules. And so our units we can see are going to be joules divided by Kelvin. And 100 over 50 is 2. And of course, for significant figures, I suppose we should write 2.00. But the units themselves are kind of weird because they are this hybrid of energy and temperature. So it's joules per Kelvin. So this increase in entropy of the reaction means that the reaction itself, the molecules inside, are more messy, or rather there's more disorder, or rather there's more microstates. So now the system's got more ways to arrange itself with exactly the same temperature. So that's the more precise definition. I'm not going to mention microstates too much more past this point, not because they're not important, but I think it's probably okay just to talk about disorder. And just remember, there's always a little asterisk next to the word disorder that says, don't really mean disorder, really mean microstates.